Well, good morning. And this is Dale Lutz talking to you live from beautiful Surrey, British Columbia. And I'm joined this morning by my friend.
Dave Campanis, good morning.
Yes, that was a tough question to hit you with, Dave. So with luck, our audio is working. We always at SAFE are very excited and nervous when it comes to audio. So hopefully you're hearing us, and thank you very much for joining us this morning as we are talking about Teradata. That's what you're talking about this morning, Dave?
Yes, it is. How to load data into Teradata, how to make use of it within FME.
Good. So I know Dave's been working hard on a variety of, let's see, on a variety of demonstrations today, and so we'll look forward to seeing them. So yes, we've introduced ourselves already. I'm one of the co-founders of SAFE, been around here since the beginning of time. Dave, tell us a bit about yourself.
I come from a background in the mapping industry, and I work here at SAFE as a product specialist in our support department, helping people use FME to better solve their problems. And I've been here for 8 years.
When the going gets tough, they come to you, Dave.
Yes.
But Dave actually was a customer of ours prior to this, and has the distinction of being one of the first customers to actually build a plugin into FME.
Yeah, it's not very good.
You're too humble. So we have with us in spirit anyway, Mark Stokes, who we can tell he's around because he's brought in the beautiful muffins that he always does. Thank you, Mark. And so he's standing by to answer your questions. And we do encourage you to answer questions or to ask questions. And you can do that in your fancy GoToMeeting. There's a little arrow where you can use that to answer questions or to ask questions. And we will be tracking those as we go. At the very end, we'll have a little bit of a time where Dave and I will look over the questions and chime in if any are flagged as being interesting for the whole group. And we'll go like that. So just a few words about us. We are SAFE Software. We are located here in really a suburb of Vancouver. About between 90 and 100 people. I can never keep track of how many. We've been around since '93, so some of us are getting a bit older than others around here, and some of us are feeling it a little bit too. So, but anyway, that's what we're up to. We build a product called FME, which long ago stood for Feature Manipulation Engine. We almost never say that anymore. We should probably change this slide. The acronym has ceased to have meaning in some ways, but what we say is that FME is this product that powers the flow of spatial data from wherever it is to wherever you need it to be, and arguably it just powers the flow of data of all kinds. It doesn't have to be spatial. And so in a Teradata context, FME is actually a very worthy tool, even if you aren't dealing with things that are spatial. Now, we have invested enormously in our spatial support, but that's not to take away from our ability to do non-spatial things. So FME sits in the middle between all these different data formats, and you can see there's all kinds of families of data formats, and today we're talking about a particular kind of database, and that's just one of the many leaves around the outside of this hub. So we can move point clouds, rasters, CAD, GIS, 3D things. Not all of these types of data can be stored in Teradata. I don't think Teradata does full 3D objects yet.
No.
But someday it might, or nor point clouds. But certainly things like traditional GIS data and CAD data, which is the primary use case, can certainly find their way in and out without problems. And so when you're using FME, you're converting data. Another key part is that the data may not be precisely in the structure you'd like it to be in your Teradata database. So if I'm starting and one of my groups has given me a shapefile that has a certain set of attributes, and I go, wait a minute, my DBAs have already made me a Teradata table for this thing, but the attributes are not named the same, then FME gives you a very nice environment for doing that type of simple data model transformation. We do all that in this tool we call Workbench, and I suspect, Dave, you're going to spend a lot of your time in Workbench today?
Almost most of it.
Yes. So Workbench lets you author the data flows from wherever your data is to where you want it to be. I suspect if Dave is honoring the webinar, most of the time the right-hand side where he wants the data to be today is going to be Teradata.
Yes, it will.
Look at that. Okay, I didn't even look at his examples, but I thought that would be what he would do. So you draw these graphs, you plop down these blue things we call transformers, which allow you to rearrange or adjust the data. This particular one creates labels. We're quite proud of that one. It is an extra cost item, but boy, does it ever make cool labels. But we're not talking really about labels today, are we?
Not really. No.
Okay, but I'll just mention that, man, I love those labels. But there's about 500 of these different blue boxes that you can pop down that do different things. And so for simple situations, you only need a handful. But again, when the going gets tough, there's a tool for just about everything other than unplugging your sink that FME has in it right now. So that's in Workbench. Now, when you author these things, you can run them interactively in Workbench, and I suspect Dave will probably do that today.
Yes, I will.
But you can run them from the command line, or you can push them up to FME Server. We're probably not really going to talk about FME Server much today, are we?
Well, we won't be demoing it. We might chat about it a little.
Okay, yeah. But FME Server is a way to take these configurations and then run them on a schedule, have them in a managed environment, let people run them in response to stimulus from the environment, like an email arriving or a file showing up in a directory. Then these things can, basically it automates the data flow processing. Or as I say, you can just go to good old-fashioned .bat files if that's the way you roll as well. So that's probably enough on Workbench. Before we go much further, let's go out to the polls and ask people what's their level of FME expertise. So here we go. The polls are now open, and I know that people are feverishly answering. So thank you so much. It looks like we've got a pretty good spread there. We'll let it go for another second or so. It looks like, I forgot, is it called a bimodal graph? I'm going to stop it there. Okay, thanks very much. Let's see. Whoa, there's how I close the poll. And now we're going to show the results. And we have what I would call a bimodal graph. So we got a big chunk of you that have never used FME, so thanks so much for tuning in today. And a really big chunk in Canada, that would be enough to get you a majority government, 45%, that are intermediate. So you're not considering yourselves experts, but you certainly know your way around to some degree. So we will tailor our talk accordingly. Oh, I have to push this button to advance. Yes, for those of you that are brand spanking new, we're not going to, and some of our webinars jump in way deep early. This one is a little bit more of an introductory one. I don't think your workspaces are super duper complex today.
Not by my standards, no.
No, yeah. So you're probably not going to have too hard of a time following Dave, but if you want to get even a more basic introduction, we've got the Get Started page off of FME Lee. So you can certainly give that a spin, or you can attend one of our weekly FME Desktop overview webinars that I guess there would be one tomorrow, actually, that our friend Craig Vernon runs. But I'm not sure who's doing it tomorrow, because tomorrow is the kickoff of the FME World Tour. And so all the people that normally do it tomorrow are at the FME World Tour. So you tune in and see who's doing it. But it's an introductory thing that can help you get started with FME. All right, so we're going right back to the polls and asking what kind of data is likely to be stored in your database. So just to get a sense of how spatial is this crowd, how non-spatial is this crowd, how rastered is this crowd, I can get a sense about how rastered this crowd is. And some databases do store raster. There's strong opinions about if that's a good idea or not, but Teradata doesn't actually store raster, but I don't think, does it, Dave?
It may be able to.
We could do it.
I think so.
We could do it because we could use tricks like they used to use with SDE in the beginning of time, and that is chop the raster up into little blobs and little images, tuck those into the database as blobs with their bounding box, and now we've got a raster image server.
Yeah, and if the bounding box is the geometry, you can actually still run spatial queries against it and get the rasters back.
Exactly. That's long ago. That's how we used to do things in SDE when I was a young man. Okay, so not surprisingly, most of you, 2/3, looking at spatial. And there's a few of you with raster, so we've just given you hints about how you could do raster with Teradata if you wanted to, and it would be actually a fun exercise to do that. All right, so let's go back. And just in terms of what we're going to be doing for the rest of our time together, Dave's got some actually a very interesting suite of demos, I think. First of all, he's going to look at bread and butter, reading and writing. Then you're going to dive into some of my favorites, the database transformers, and look at executing SQL, I'm guessing.
Yes.
Do you say SQL or SQL?
I say SQL because I'm lazy.
Okay. It's fewer syllables, maybe. So that's good. We should ask the audience what's the correct way to say that. Some additional things, and I suspect this is about doing updates, Dave, that business of supported database functionality. You touch on that a little bit?
Well, yeah, I mean, essentially the first few workspaces are going to be fairly simple, just to show you what we can do with your data. The last two workspaces will be more practical examples to sort of show you how you would use it in a real-life situation.
Right. I think you're even going to fire up ArcGIS today, aren't you?
Yes, I am.
Hey, that's always a treat. So you're going to get to see some Teradata working with ArcGIS, and that's probably where he's putting it all together. And then afterwards, if you want to watch this again in slow motion, you can get our recording. I know Stephanie will be putting that up pretty quick, and then we'll actually chop this up into little pieces. So if you just want to hear your favorite quotes, they'll be available in probably 5-minute segments afterwards. All right. I think at this point I'm going to hand it over to Dave, who's going to roll up his sleeves and go where he likes to go, and that's technical.
Yeah. Okay, the first thing about the Teradata reader-writer and FME is it relies upon the Teradata JDBC drivers. Now, these are not installed with FME. So the first thing we need to do is install these into our FME, and the way to get them is to download them from the Teradata website. Now that's the URL right here, and if I've already brought up the Teradata website, and it's the JDBC drivers here. Now this site requires a login. But it's you can set up a free account. They don't charge you anything. So I've already logged in. We want the 13.10 drivers. The Teradata JDBC reader-writer only reads Teradata 13.10 at the moment.
But top people are working on that right now.
Yes, yes. But we will, when we extend that, we'll extend that going forward. We won't be using it to read the earlier versions of Teradata. So we'll download the drivers, say yes to signing our license.
I don't think you read that carefully, Dave. Did you read that carefully?
Never do.
Okay. Don't tell Angela.
Okay, we open up the zip file, and in the zip file are a couple of jar files and a README. We don't need the README.
You don't read that either?
No.
Okay, so then
I don't read a whole lot.
You got to find out where your FME is installed, probably. Ooh, looks like you got a few FMEs there.
Yeah. I always figure more is better.
Yeah.
But in this case, we're going to install it in FME 2013 Service Pack 1. Now, the Teradata reader-writer is available only in Service Pack 1.
Yes.
So if you don't have Service Pack 1 installed, go to our happy little download site, which is fme.safe.com/download, and grab yourself a spanky new copy of FME. There's lots of good things in Service Pack 1.
One of them is a really good Teradata reader-writer.
Yes, it is. Now there's a whole lot of folders here, but the one we're interested in is the plugins folder. And just scroll down to see files, and we'll just grab those.
You just drag it right in there anywhere.
Yeah, drop them in there.
But Dave, they might be harmful.
Yeah. Living on the edge, people, living on the edge. Now I've already done this, but we'll just copy and replace. And
that's gutsy. He's replacing it with what he just downloaded.
Yeah, normally when you first do this, it won't say copy and replace because you won't have them.
Okay.
But in this case, I would already install them, so we do. So there you see there our new drivers are there, and that is all that is required to get Teradata up and working with FME.
Now, I know the database team assures me that if you forget this step and you try to do stuff with Teradata, it gives you a reasonably good error message that points you at this website. And
yeah, it will say you don't have the drivers, please install them.
Yeah.
It's nowhere near as cryptic as most of our error messages.
So. we worked hard to make this one good. Okay,
so we've done that. We've installed the drivers, and we're all happy. So, okay, I think we covered that the versions and additions. FME 2013 SP1 is what we require to read and write Teradata, and we read and write to Teradata 13.1. Now, to read Teradata information, you need to have the professional version of FME or better. That is effectively our true base version. We don't
Yes.
generally have too many people
Almost
using our
nobody
base
buys
version.
the base version.
Exactly. But to write to Teradata, you will need the Enterprise Database Edition. So the Oracle or Microsoft SQL Server, IBM DB2, they're all pretty much a database edition of FME.
Yeah.
And that is the level you will need to write your Teradata information. Okay, and we have another poll.
Frustrations. Okay, so let me go and launch the poll. And let's see. What are we asking here? When you're working with a database, what don't you like? Those are interesting things. I think it's fun. I used to be a DBA in my youth, so I don't know why anybody would think that it's a bad thing to spend time working with a DBA.
Ooh.
Some of my best friends were DBAs. So, that looks like it's a popular choice, actually. Okay, yeah. And, yeah, I mean, some of these things can be frustrating, I know. So that one of the interesting things with FME is you can totally use FME without knowing a bit of SQL. Or you can roll up the sleeves if you think in SQL and dream in SQL, you can use FME that way too.
Yeah, we're going to show you both ways of doing things, but we do have some good SQL tools. So if you are wedded to your SQL and you've spent 45 years learning SQL to the best of your extent, we'll let you use it.
Yes. So there's a few people choosing others, so I'd really like to know what that was. You can type in the question thing and tell us what the other frustration is, indeed. So I think we'll close the polls there. So thank you very much. And actually, let's just share those results. So it's pretty much everybody's frustrated with everything is how I would how I would interpret this. So hopefully we can show you some pain relief for some of these frustrations.
Well, I think the first two, we can definitely ease the pain there because like I said, we have non-SQL tools, and a lot of the work we do within FME avoids the
Yes.
the need for using intermediate tables.
Yes, you still need a DBA at least to give you a password and an account.
Exactly.
But you can create tables with FME.
Yes, you can.
And
it's a smart creation. If the table already exists, FME will use it. If it doesn't exist, we'll create it on the fly for you.
Right. So there we go. So thank you very much for sharing that with us. And I think that, as Dave mentioned, we do have some pain relief in store for some of those frustrations.
Yes, indeed. Okay, so before I go for the demo, some of the things we're going to cover, tips and tricks. One of the key things is that Teradata must have a unique field, and it doesn't really create one on the fly for you. So within our workspaces, we're going to be cognizant of that.
So you have to, if I'm reading it from some crazy old shapefile that didn't have any ID field, you're going to have to make one in the workflow.
You're going to have to create one, yes.
Okay, and that's a Teradata issue, or like basically a fundamental thing of the Teradata database. They
want all the combination of fields must be unique, but at the same time they don't actually create on the fly their own primary index for you, so you have to do it yourself. And these are some of the other areas we're going to cover: transaction size, published parameters, and the writer modes, etc. So let's hop right into our first workspace.
I'm excited about spatialization too.
Okay. Okay, let's bring that up.
Hey, there's Workbench.
Yep, that's FME Workbench for you. And just to explain some of the parts for those of you who are new to FME, this is our essential working tool that lets you create your processes to work with your data. Let's open up our first workspace, and I'll show you some of the parts. Okay, so our first workspace is essentially loading data into Teradata. Over here on the main canvas, as we call it, we have the workflow itself. So you have in the brown, you have the readers features. In the tan, you have the writer features. And gray means these things are disabled at the moment. If I enable this, you'll see that in the middle we have the blue transformers that Dale mentioned earlier. These transformers actually are what do the work on the features as they go from the reader to the writer. Now, in some cases, you don't want to manipulate the data at all. You're just going straight across, and then that's a fairly simple workspace. We do give you the option of sort of remapping attributes on the fly in a straight across. In this case, I'm mapping the AutoCAD entity handle over to an entity ID, and I'm doing that to establish that unique field for Teradata.
Right, and so this is coming from AutoCAD, and in AutoCAD there happens to be a unique identifier for everything that's flying by. You're just reusing it.
Yeah, yeah. Okay, so let's just quickly run this. Oh, I should explain. On the left-hand side here, the navigator, this lists your readers and writers, and this is where you can set all of the settings for the various readers and writers. So for the AutoCAD setting, has a whole bunch of options. Do we want to expand blocks? Do we want to preserve and so forth? Most of these are relevant if you know AutoCAD. You notice most of them are green, but we've got some in purple.
Yeah.
The ones that are in purple, what we've done is we've published those parameters. If you look down here, we have published parameters, and now these are all the things that are of immediate use to the people who are going to be using this workspace.
Over and over again. If somebody wants to run this again,
yeah,
this is where they can fill in the specific information.
Exactly. So if you're doing AutoCAD files, well, you probably want to choose the AutoCAD file itself. So we have a few things published here. We have an Oracle reader up here, so we have the Oracle service, and the Oracle login information is published. We have the map info source for our map info section down here, and we have the AutoCAD source published as well. And then for our Teradata writer, we've also published the Teradata host, the database, the port, the user, the password. These are all things that would normally need to be
Dave,
set.
if you hit that sort of run with the question mark button, does it give you a nice form?
Yeah, that's the
right.
run with prompts, and that will prompt you and ready to go. If you're making a workspace to send off to other people to use, generally you'd leave all these things blank. So it would force them to enter the data so they don't use your defaults.
For sure, you'd blank out the password.
Yeah. Yes. Yes. You definitely want to do that. Okay. So those are the published parameters there. Now, one interesting thing I'm going to point out here, and just sort of showing off the cool things we can do in the AutoCAD file, in the AutoCAD source. You notice we pick up a DWG file here, and that's the DWG file there.
Yes.
But in the map info source, you have an option of picking up a tab file or zip file. Hang on.
Yes.
I may have done something wrong here. Yes, I did. Oh, that's right.
No, it's good.
Okay. So you can also open zip files.
Yes.
As well as tab files. So in this case, I've actually picked the zip file.
Yes.
So
it's going to basically unzip that and let us just read it.
Exactly, and all of our data sources, our file-based data sources, can read a zip file as well as the main file.
And in fact, if that was sitting on a website somewhere, you can put the URL to it as well.
Oh, that's cool.
Yeah, you can go http://dale.zip, and it'll do the right thing.
Okay, so I think we're good to start our first translation here. So we'll push the button and let it rip. So now we have a log window down here that tells you everything that's going on. It tells you a lot of stuff you don't need to know.
I can see that we're creating a table right now. That's always exciting. Another one. Oh, there's quite a few tables.
There's a few. There's all these three tables up here. They're water meter and water.
There goes the commits.
Okay, and so then it tells you your features in and your features out. Now, even though I have this section disabled in here, it still read the map info data, but it only wrote out the three layers from the AutoCAD file. So what we're going to do is we're quickly going to take a look at that data. Now we have a product called the Data Inspector, and you can bring it up through this window here, and then we can sort of file and we can open the data set.
Hey, that's you must have looked at this earlier today, I bet.
Yes. However, unfortunately, it doesn't remember all the fields.
Ah, but you could save them in your defaults down there.
Yes, you can.
So actually, we should show folks that if Dave's always doing this, he can go down to defaults there and say save as my defaults, and then he'll never have to fill this in again.
Yep.
Is that who it is? Okay, he's going to get a table list, and we should see those water things if we are at least a bit lucky.
Yes, we'll have the water lines, water meters, and water nodes tables.
Yeah.
And let's hit OK and OK. Now we're reading directly from the Teradata database.
And going to render.
Yeah.
Whoa, okay.
There's our data. All happy.
So this is shipped with FME is this thing we call the Data Inspector to let us snoop around and see what's going on with data.
Yeah, it's very good if you're getting data from a source and you're not exactly sure what it's all there. Throw up in the Data Inspector, and the Data Inspector will show you exactly what FME sees about your data.
Which should be pretty close to the gospel truth.
Yeah. So in this case, I just highlighted a feature here, and you have all the attributes.
Yep.
And their values. You have the geometry at the bottom here, so you can go in and examine the geometry in great detail. Tells you what kind of geometry, the line, bounding box, feature type, etc. So everything you need to know about the data is there.
Now, Dave, I just got to ask you to show us the table view.
Okay, that is actually coming up.
Okay.
Soon.
Okay, so I won't then spoil your demo.
Yeah.
But if you're a database person and you're not used to seeing graphics with the individual attributes, yes, there is a table view coming.
Okay, so that was the pretty much the simplest translation you're going to get. Like I said, we created the unique ideas. We wrote over the information. So let's turn off the AutoCAD section. And next, because Dale really wants to see the table view, we're going to move over to the non-spatial to spatial section.
Oh, you're spatializing for me.
Yeah, so here what we're going to do, and we're going to show you another neat way to bring up the viewer, or the data inspector, is you can click on a input feature and go inspect, and it will come up with the correct writer. Now in this case, it doesn't remember all of the username stuff, so we'll throw that in. And this is the address points table. So now this is the table viewer.
I do love the table viewer.
We've just added. So this is non-spatial data. So by default, if there's nothing to show spatially, we bring up the table view. And this shows you standard sort of table view, and you can scroll through and see all the information in its native state.
I bet you can actually click on a heading and sort too. Have you ever tried that?
Nope. Let's give it a shot.
Looks like that already might have been sorted that way.
Okay, let's sort by zip code then. Aha.
Yes, it all works.
That is nifty.
Okay, that's great, Dave.
And we've established that is indeed non-spatial data.
Yes.
And what we're going to do is we're going to run it through a few transformers to spatialize it.
Yes.
Now, I should have left it up, but we can also see here all of the attributes that are attached to it.
There's an X chord and a Y chord down in there.
Yeah, these are going to be very useful coordinates, or very useful piece of information. So what we're going to do is we have we're going to rename a few attributes first to
match your desired output schema, I guess.
Exactly. Then we can use a 2D point replacer, taking the X coordinate and Y coordinate. What this will do is take those values and create a point at that location. So it's turning non-spatial coordinate information into a true geometry.
Dave, they want us to zoom into the bookmark there.
Okay.
So you can see.
To zoom in and zoom out, you can use this nifty little slider here.
Yeah, so go in a little bit and then slide her on over.
There we go.
Look at that. Wow, that's cool.
Yeah, okay.
I guess some of our pro services folks are needing stuff a little bigger to read.
Yeah, I know I'm getting old, and I require those big 27-inch monitors. Hint, hint. So now the 2D point replacer gives us a basic geometry, but anyone in the GIS mapping field knows the geometry doesn't mean anything unless it's attached to coordinate systems, so you know where in the world it is. So the next step is we use a coordinate system setter, and we know this data is in Texas, so we give it the Texas state plane central foot coordinate system. And there's a whole list of coordinate systems to choose from here. So I think there's 3,000 or 4,000 odd. So there's oodles, in other words. So because there's so many, we actually give you a nice little filter down here. So if we want all the ones that are in Texas, we can just type TX.
And Texas gets a lot too.
Yep.
It's a big place.
Also, if you know the EPSG number, you can just type that in, and it will find the EPSG number coordinate system and its corresponding FME native coordinate system as well. Okay, so
you're setting it. That must mean that the Teradata is going to remember the coordinate system.
Yeah, it's coordinate system aware.
Very good.
So now let us run this section, and the other thing I did here is this is a very large table, and we're kind of short on time. So there is a section in the reader where you can set the rows to read at a time. Oh, sorry, not the rows to read at a time. Yeah, you can set the rows to read at a time, which gives you your transaction size.
Right, so that's a bulk read thing.
Yeah, but what you can also set is maximum features to read. And this is handy if you're prototyping a workbench and you got 3.5 million records in your table. It's going to take a long time to test it out. So you can just set maximum features to read to 1,000, and that gives you an idea of what's going on and not take up too much time. So I've done that, and we will run this.
So we're going to grab the first 1,000 basically,
Yeah.
and you're spatializing them. Oh, you're still rereading those AutoCAD ones, I guess. We didn't disable that.
Yeah, I did not disable the reader, just
Okay, there it goes.
Okay,
But
so we're gonna have a look at these.
address
Inspect.
points geog got 1,000.
Yeah.
I can tell from the stats. I love those stats.
Oh yeah, I guess I should point that out. Okay, well, we'll load this up first. Teradata Spatial.
All right. I wonder what your password is.
Well, I like used to like better when dev was less to type. But we pick the address points, and we'll load that up.
So this should be some point geometries. And I'm going to...
So there's our first 1,000 points, essentially. And if we look at one of those points over on the screen here, we'll see that they have all the fields that the
and I'm pleased to see Texas 83 Central.
Yep, it's got the coordinate system. It is stored. The FME point geometry is stored, and all of the attributes are stored. So that's your basic spatialization.
Good. So we took non-spatial stuff in Oracle, spatialized it. Now, I don't think you're going to talk about geocoding today, are you, Dave?
No.
But that is something that is another way. In this case, the input data had an X and a Y value, so we could spatialize. But there are ways in FME to use external services from other vendors to geocode, which means to take an address and then find out where that really is on the Earth. So in particular in Canada, DMTI has a great geocoding thing built into FME. We're working right now with our friends at Esri with ArcGIS Online, has a really good geocoder. So if you have an ArcGIS Online account, we'll be able to make use of that. And our friends at Pitney Bowes with their Spectrum geocoding thing, where we've got a prototype underway for that too. So all of these are ways in the middle. Basically, one of these blue boxes of Dave's would say DMTI or AGOL or something like that, geocoding. You pump your data in with the address, and out comes the spot on the Earth, and an indication if it worked or not, because there's bad addresses out there, and then if it's bad, you can route that somewhere else to.
Yeah, throw in a tester to test your results, see if you get a good address, and then root it up. We'll actually show some QA options coming up in some of the next workspaces.
Okay.
So the last section in here is we're going to go from map info to Teradata. Now, in this case, we're going to add a little value to the data. So we're going to calculate the area of these polygons as we read them in. And because we don't have a unique ID like we had with the AutoCAD up here, we're going to add a counter. And this will essentially just count the features as they come in and establish a unique ID for them. Okay.
Okay, another way, like in this case, there was no unique ID, so you're making one on the fly.
Making one on the fly.
We also can generate UUIDs if
you want something long and
really
complex
big
or non-numeric.
Right.
Yeah. Yeah, well, then there's GUIDs as well if you need something that's geometry geometry unique.
Yeah, that's right, the GOIDs. The one thing about the counter is that this starts back at 0 every time you run. So if you were doing it over several tables, you might get into a problem.
Yeah. The possibility is you always use a SQL executor to sort of find the maximum number already used in the table, and then the counter has an option here to set the count start.
Yes.
So you could read the last number in the table and set that to your count start automatically.
Yeah. Select star from dual. Isn't there some scary thing like that Oracle people do?
Yeah, perhaps.
I think that was a way to get numbers. I don't remember what it did.
Yeah. Okay, so we'll run this quickly.
So this time we're only doing the map info in. We disabled the other parts. Normally you might do these all in 3 different workspaces. Dave has just done it in one and then turned parts off and on just to kind of keep us from jumping around all over.
Yeah.
Okay, so we're writing there, are we?
We are writing.
So these are parks from the city of Austin?
I believe that's where they are. That's from our FME data set, our demo data set.
It's only fitting that we're kicking, at least I'm kicking off the FME World Tour in Austin. It's a pity I can't actually have time to go see these parks.
Okay, let me just make sure everything's... Oh, okay. I forgot about this. This is a little quirk of the Teradata JDBC reader writer in that you cannot have the data inspector open looking at a table and write to it.
Oh.
We're working on that.
Top people?
Top people are working on that. but it catches even me sometimes. There we go. So that
Oh
was nice
wow,
and quick.
that
Yeah,
that was
much
fast.
quicker.
I,
Yeah.
I was wondering how many hundreds of features this was.
Uh,
Okay.
okay, so let's have a look at our parks.
Oh, once again, you got to do a little dance here.
Yeah.
I really should get you to save this as your default, Dave.
I think I will.
Okay, so there we go. Guess the password. He's going to save it as his defaults. There we go. So it'll be there forevermore. It's a good thing to do for databases if you're always working.
Yeah.
I see Raven is around this morning. Oh, please.
Yes, he's our emergency backup.
Thanks, Raven.
So there are city parks.
I know these well. Wish I'd actually have time to go visit them sometime.
Yeah. And we have our park area, our name, and some of these also have.
Your primary index must be your number that you were assigning.
Yeah, that's the number that we created. So every park now has a unique ID number on it.
Yep.
Now, one thing about the data inspector, if an attribute has no value, it is not displayed on the screen.
Yes.
So that sometimes you see we have names, and others we have a name and a alternative name.
Got it.
So,
I think that for those that are in love with nothing, Nulls,
yeah.
In FME 2014, our friend Ty, one of our top people, is basically doing nothing.
Oh, there you go.
He's adding nulls as first-class citizens. So in the future, you would click on that and see that column has null.
Yeah, that's very, very Seinfeldy job description.
It is. It is.
Yep. So this, I believe, is pretty much everything we're going to be doing in this workspace. So let's close that up and move on to our next one. So you can just close it by hitting main. Do we want to save that? No.
All right. So what's next, Dave?
Next workspaces are a bit simpler. Our next one we're going to play with is the SQL Creator.
I love this.
Now, in the previous workspace, we were using actual readers to read the data from the various feature types, or for the various data sets. But the SQL Creator for databases is kind of an alternative to a reader. So it's a transformer, has no inputs. You can treat it as a reader. But the cool thing about it is that you can set up the reader here and all of its parameters, but then you can give it a SQL statement. So in this case, I'm going to say select star from city parks where name is Big Walnut Creek and alternative name is Greenbelt.
Okay.
So we're supplying the database a SQL statement, and we're taking the results back, and we're reading those results themselves.
And I noticed right here on the left-hand side it says create published parameter. This would be where if you wanted to prompt somebody at runtime for the name, you could basically double-click that, drag it in there, and now that puts a variable in there that would be filled in at runtime.
Yeah.
In your case, you've hard-coded it, which is totally cool. Oh, what are you doing there?
Pushing buttons at random, and let's see what.
Whoops.
Okay, so it's not happy with this.
That's okay. All right.
That's probably why it was closed and blacked and grayed out.
Yes.
So we've set the SQL statement.
Yeah.
And we're reading from, let me show you, we're reading from the city parks that we just created, and then I just showed you in the inspector.
So you're looking to pull a very few things.
Yeah. So let's run that quickly and see what we get. Lo and behold, we get just one park.
Yes.
If we click on the park, its alternative name is Greenbelt, and its name is Big Walnut Creek.
And of course, that you could have a very complicated join going on in there.
Exactly.
And I know in your youth you've done some Teradata joins with tessellated things to do spatial index stuff. And you could do it in there, probably.
Yes, you can actually build a very complicated SQL query. And the nice thing about this is that you can sort of build in your joins from multiple tables. And what FME does is it takes all of that process and it dumps it on the database engine.
Which is what Teradata lives to do.
Exactly. Database engines are very, very fast at executing SQL, so we let them do it.
Yeah.
And then your FME machine doesn't actually have to do a whole lot of work.
Yes.
So that's the SQL Creator. So
you should show folks, Dave, how do you put a SQL Creator down? Can you show them how someone would do it if they're starting with from blank?
Sure. We have a transformer gallery here with the transformers. Now the all list you see has 504 transformers.
Wow.
That's a lot of transformers. We have a categorized list, which is somewhat nicer.
There's 9 database ones I saw.
Yeah, so we have a whole bunch of transformers in there. Database, there we have the different queries, SQL Creator, SQL Executor. If you want, you can double-click this, or you can drag and drop. But the way that I use all the time, and this is the coolest thing, is you want something SQL related, you just type SQL on the canvas, and it comes up with everything that starts with SQL.
Right.
We can pick a SQL creator there. And really, once you use this, you never go back to this old way.
Yeah.
And those of us in support, sometimes we have to use older versions of FME that didn't have this, and it's hard.
Yeah, you just type, once you know your handful of transformers that you use, you just type them and go.
Yeah.
Okay, so that was the creator. That's pretty good, and basically lets people execute SQL.
Yeah, and there's another SQL transformer that we're going to use, as well as the SQL executor. Now, the difference between the SQL executor and the SQL creator is the SQL creator did not require any input features.
Right.
The SQL executor uses input features, and what it does is it uses these input features as a trigger so that your SQL can interact with the feature that's coming in.
Yes.
So in this case, I have been given
looks like you got a text file full of SQL statements.
Pretty much, and I'll show you what it looks like right here. So this is somebody, I've been sent a whole lot of SQL statements.
Oh, you're just going to play them back.
Yeah, in this case, we're just using it as a SQL player.
Right.
So there's a create table, a whole lot of inserts, and then at the end, which is kind of cool, creates this really funky view that has a really complex SQL to create.
Got it.
So what we're going to do is we're just going to read all these and feed them directly to the Teradata.
So, well, yeah.
Okay. So in the SQL executor, I've got the standard reader SQL, the SQL reader here. Now, even though we're kind of writing things to the database, we use a SQL reader, or we use a database reader here rather than a writer.
It doesn't really know that we're up to wild SQL.
Yeah. So what it's doing is it's going to take the information from your input feature. It's going to send it to the reader, and then it's going to expect to get features back.
And it's going to be surprised when it gets none, but it's not going to be too stressed.
Yeah, it doesn't worry about it. Yeah. So you can use this both for doing queries based on existing features. Say you have a feature that has certain attributes, and you want a matching feature in your database that has those attributes, or has some matching attributes, and you want to join them together. You can do that. Or in this case, if you just want to feed a bunch of housekeeping SQL to your database.
Yes. Now, normally you wouldn't be reading the whole SQL statement. Often you're gluing one together from various pieces inside of your database. But this is just a nice, simple example.
Yeah, and you have options to this. And I mean, here I've just set to attribute value.
Yes.
You can also open up an editor where you can pick the feature attributes, you can pick public parameters, you can pick feature functions, and you can actually build up your whole SQL statement through here using all the information from various parts of FME.
The ID equals the ID that came in from the feature.
Yeah, yeah.
So you basically read a bunch of stuff that seeds the query. But that's not what Dave's going to do here. He's going to just pump some SQL straight in there and create something. So what is this actually creating?
It's creating a table. It's populating the table, and it's creating a couple of views. And it's one of the views is that tessellated indexed view that I don't really understand much, but is really cool in Teradata.
Yes, there you go. So you did it.
So one of the things we're going to do here is we're going to pop back to our happy friend, the data inspector, and we're going to close this out. And I'll show you what we can also do is we can read not only tables, but let's go back here and I'll show you. The last line here, we created a view called customer AOI.
Okay.
So we created a view. That's not a table, but notice that it shows up in our data inspector.
Yes,
so we can read views as well as tables.
That's a happy thing.
So, and again, all the horsepower behind the view is all being dumped on the database engine.
Where it belongs.
Yeah, so it's almost like a little SQL creator, but has a permanent view.
Yeah, yeah.
And again, we can read these points, and it's got the attributes.
And our stores and customers and things, yep.
Yep, so all the attributes of the view are available.
Got it.
Okay, so let's close this down.
So that was your executor and showing views.
Yep. So that's fairly simple as well. So let's just try the next one, which is the feature reader. Now the feature reader is somewhat similar to the SQL executor in that we're going to interact with a trigger feature to read data from the database.
Yes.
So in this case, what I've created, let's change this up a little bit. Just throw some inspectors up there. So I've created a bounding box here.
Yes.
With some data. I'm going to send that bounding box to the feature reader.
Yeah.
So the feature reader is set up to read the Teradata database.
Yeah.
If you click on parameters, it's going to read the parks database. And it's going to query the features that I picked earlier. And you can also put an aware clause here. So if you want to put, pick by attributes as well. And then I'm going to say select only features that intersect with the initiator's features bounding box.
Got it.
That's a simple, is it inside the bounding box? And you also have more complex geometric queries here. And keep the results. So let's run that quickly.
So that's doing a spatial query. Oh, okay. So, so you see the bounding box and the one you.
That's the one I selected.
Got it.
So yeah, we only grabbed the city park that is within that bounding box.
Yes. Good old Big Walnut Creek.
Yeah. So
I think that's where Little House on the Prairie was, I think.
Ooh, that's way too old even for me.
Yeah. I'm pretty sure Walnut Creek, but maybe we'll see if anybody knows.
Yeah. So I mean, these are pretty much the simplest. I mean, I've been running workspaces here with just a single transformer to show you what they can do. Our next set of our workspaces, we are going to start putting these things all together and doing some useful workflow. So moving into the next, let's see. Okay, so these are the practical examples. The first practical example is we're going to update a spatial table using ArcMap.
Wow. Okay.
And FME. And then the next one is we're going to just QA some CAD data while we're importing.
All right. So that means you're going to fire up ArcGIS now?
We're going to, well, before we fire up ArcGIS, we're going to shut down our FMEs. And we are going to make sure that FME has the ability to extend ArcGIS. And what this means is that FME is actually available within ArcGIS, so you can set up connections through FME.
Yes.
You can actually, within ArcGIS, you can actually create workbenches and stuff, although we're not going to go into that today. But the first thing to do is make sure that the FME extension for ArcGIS is extended.
So this is this thing called the FME Integration Console. You ran this app, and you're going to go hit that button.
Yeah, so we hit the extend button. Now, I think this is extended by default on some installations. I think where your ArcGIS has a standalone license will automatically do this. If you're using off a license server, I think we don't.
That's something like that, yeah.
Yeah.
So anyway, it's always good to double check. We know that now you know that you're extended by FME.
Yep. So we'll close that, and we'll fire up ArcMap.
10.1.
Yes. But we extend earlier versions.
Yeah, we extend before and after 10.1, but I'm not allowed to talk about what comes after 10.1.
Oh, okay.
You can probably guess, though.
Okay, so there's our ArcMap interface, for those of you familiar with it. Now, in the catalog, what we are going to do is, oh, okay, well, let's delete that. Sorry, I should have deleted that before. We're going to add an FME connection.
Yeah, pretend you didn't see what was there.
Yep, didn't exist.
So you're going to make an FME connection.
And we're going to add an FME connection, and we're going to hook up to Teradata.
So this actually would work in older versions of ArcMap as well.
Yep.
This exact same thing.
And we're going to load on our happy little city parks table. There we go. And we're going to go OK.
And you're golden.
Yeah, now we have a connection here. So now this is simply just drag and drop the connection in our ArcMap. And we have our city parks.
That's cool.
However, notice on the side there we have 4 different data types.
Yeah.
Now what it is that ArcMap only allows one type of geometry per table, and Teradata allows multiple types of geometry in a table. So what the connection's automatically done is created a filter to make different data sets by the geometry. However, we don't need these. We know we only got polygons, so we're going to just get rid of these. There we go, remove. We just have the polygons. Now we want to edit these, but unfortunately, we're not allowed to edit a connection because this is a read-only.
That's right. FME only supplies a read-only connection, so I'm really curious what you're going to do now.
Okay, well, what we're going to do is we're going to take the data and we're going to export the data.
Okay.
And we're going to export the data into a geodatabase.
Okay.
So the parks.gdb, actually, So we'll pick the parks table.
Yeah.
And we'll save. Would you like to overwrite it? Yes.
Because I bet you did this before.
Yeah, it's rehearsals.
Yes. So anyway, basically you're doing a translation inside of ArcGIS
Yeah.
and using ArcGIS tools, although FME is in the background.
Exactly. FME is the pipeline that moves it
Yes.
from Teradata into ArcGIS. So the neat thing is, after it does the translation, do you want to add the exported data to the map as a layer?
Okay,
let's
that's
say
nice.
yes.
View ArcGIS.
So now we have two sets of parks, but we don't need the connection anymore. So let's get rid of it.
Right. You just use it to get a quick view, and now you're going to get rid of it.
Exactly. So now we have a parks, and if we want to edit this one, hey, this one we can edit. So now we're ready to start editing.
So what are you going to do?
Well, let's do a couple of things. Let's zoom into a couple of parks here. First thing to do, let's, okay, do that in the right order. There we go. We're going to edit one of the attributes on this park. So its alternative name is 52.
I think it should
that's
be
not that exciting.
42 is better. The answer to life, the universe, and everything. But what are you going to go with?
I'm going to go Dave, because I always wanted to name something after myself.
But then, yeah, okay.
All right. So we've changed the name of that, and if we bring up the editor again, we see, yep, it's Dave.
Okay.
Now this one, we're going to do something a little different. We're going to, we're going to make the park bigger because we want more park space.
Okay.
So we're going to noise.
Too bad for those homeowners that are nearby.
Exactly.
All right.
Eminent domain, I think it's called. So we've made a couple of modifications here, and the next thing to do is we're going to save we're going to stop editing and save my R edits.
Okay.
Now we can shut down the well, we'll leave it up and running just in case we want to look at it later. So now the next step is to run this the update workspace. Let me just bring that up.
So you're gonna do change detection?
Yeah, we're gonna do some change detection.
Oh wow, okay.
So now the first thing, this workspace is all set up to use whatever parks we had written it to. So the Teradata input is not, or the geodatabase input is not really here. So we're going to add that quickly.
You're gonna go find wherever you saved your.
Yeah, and it's happens to be right here. So we'll just grab the parks.gdb folder.
Oops.
Drag and drop it onto here. And it comes up as Esri geodatabase file geodatabase API. Now this is the API that does not require ArcGIS to be installed to run.
Yeah.
But we have other Esri APIs as well. But we'll just use this one quickly.
Okay.
And it comes up with the table that's in there. So we're going to hook this up to the input there. So now we've got the parks input that we modified. We also have an input from the Teradata table, the original data.
Yeah.
Yep. The first thing we do is there's a coordinate rounder, because when you move data between formats, sometimes coordinates can be modified slightly depending on the storage byte level and stuff they use. So I figure our data is accurate at best to the nearest millimeter, so we're gonna use a coordinate router to round to the nearest millimeter.
Right.
On this coordinate. Oh, actually, this is in feet, so thousandths of a foot. So I think that's pretty accurate.
Yeah.
Yeah. And that way, then we'll just make sure they match. The next thing we're going to use here is a change detector. Now, the change detector detects changes in both attributes and geometry. So we're going to set our geometry match to 2 dimensions. Lenient geometry matching, that just means if it's reordered the polygon and put the vertices in a different order, we can live with that. And then we're going to check the name and alternative name to see if those have changed.
Right.
Then ones that have the added is the revised data that is different than the original.
Yes.
Is going to be the output here. Deleted is the original data that is different from the revised.
Yes.
So
and the unchanged, we don't care. You're leaving that yellow because if it didn't change, we just do not care.
Exactly. We just want to isolate the changes and use those to update the database.
Right. So the ones that are added now, you're going to do some tricky thing in there, I bet. What is that?
Yeah. There's a special attribute you can use called FME_DB operation that you can set to insert, or in this case, delete.
Right.
Now, when you're using FME_DB operation, the output database has to have its mode set to update. There's a writer mode, update, and insert, and delete. So we'll set that to update.
Which puts it in this mode where it's going to look for these instructions.
Yeah, and then we just send it out to the table.
So you're going to be so bold as to run that?
We'll give her a shot. Now I've also added a viewer here, so you can view the table as we're reading it before we did any edits.
So I'm going to be interested in the numbers that appear in all those little lines. Is there a problem because we're viewing it somewhere, or?
Oh yeah, sorry. Bye-bye ArcMap.
Yeah, I wonder.
ArcMap keeps its connections open. There we go.
Seems faster.
Okay, so we have our city parks. Now let's add, you can also add a data set as well as open, and we're going to add the Teradata, the city parks, the modified ones. So there are the city parks after the changes have been applied.
Yeah, so what we're looking at here is the original old one first, or?
Yeah, the purple is the old one that I brought up from I've just threw it out to the data inspector as I had it in.
Right, was the original data.
Yeah, and then the data inspector there, and we'll read the table and we'll take a look at the ones we changed. Now let's reorder.
Drag guys up and down.
Yeah, let's see. There we go. So you can see that the changes have been applied to the database.
Yep.
And if we turn that off, nope, if we turn this off and look at this one,
info.
It's now my park.
Hey, good for you.
I've always wanted a park. Now I have one.
All right.
Okay, so
proves it works, and there's all the numbers that tell us that there was 2 things to delete and 2 things to add.
Yeah. So that's your basic change detection workspace. Now we're getting short on time.
We are. So I will not interrupt. So you just wanted to do one last thing, which was a QA thing on the way in?
Yeah. Yeah.
So quickly take a peek at that, and then we'll wrap up.
Okay.
Whoa.
So,
okay.
Yeah. Okay. This is a little bit more complex. And we want to actually, we can run this quickly, I suppose. This takes AutoCAD data, and it uses a bunch of different checkers just to say, hey, is this data to our specs? Is this data everything we want? So the first thing we use is Geometry Validator, and this is a neat tool that checks all sorts of geometry problems. In this case, we're just going to see if it's OGC simple, simple geometry. We check for various attribute values to make sure they have the right values that are acceptable. This is a neat transformer. It's called the joiner. It's another one of our database transformers, and this transformer allows you to link your data with an external table. Similar to the SQL executor, but it's got a easier interface. And
Teradata would work in there too.
Teradata would work in here too as well. In this case, we're using a Postgres database just to check on a materials table to see that it has a match. And here we're using a feature reader against a bounding boxes or bounding tiles just to make sure it's in the right place. So our data says it's in one place, it's in the right place. If any of these fail, we are sending the failures down to an XML templater, which builds a little bit of XML to create an HTML report form for the failure. So these XML templators basically create each row. We send them into another XML templator that creates the header for the output. And at the same time, this workspace is set up that it can read multiple AutoCAD files at the same time.
Got it.
Some files might pass, some files might fail. So what we don't want to do is we don't want the past features and the failed files to be written to the database.
Got it. You fail a whole file at a time.
Exactly. So I've set up a feature merger here, and if any of the features from a file fail, this feature merger checks on a special FME attribute called FME base name, which is just the base name of the file, and it will only let the features that didn't have a failed feature go through to the output.
Right, I got it.
Right. So you can actually send 14 files to this, and it'll keep the ones that pass and reject the ones that fail.
And give you a report on the failed ones so you go fix them.
Exactly.
Or better yet, you get somebody else to fix them.
Yeah, and I'll just show you quickly what that report looks like. So there you go, and that's
wow. That's one of the nicer reports I've seen.
Yeah. And the report is also it's set up. We have a thing called a dataset fan out. I'll just show you that
quickly. You get a different report for every.
Each file name has its own report file. This is the one that we were talking about server before. You could publish this up to server. Your users then would just submit a zip file with all the AutoCAD files, and it would take the ones that were good, spit back the one, report on the ones that were bad, and tell them to do better. And then you have a whole automated upload and QA system.
So I just received a buzz here on my thing. I think time is up, Dave. So what do we got last to sort of wrap up on? Okay, we'll zoom all the way down. Here we go, just to wrap up. Thank you very much. So we don't have time for any questions and answers, but please keep writing in. I know Mark is sweating there, answering all your questions. So keep him working hard. We'll stay by later. We are going on a world tour. Take a look where. Los Angeles is one of the places. I know we'll see at least one Teradata person there. But if you're anywhere around the world, take a look at the world tour. Join us there to see more about FME. whoops, and I guess other webinars coming up. If you want to see how we work with other databases, there'll be a lot in common, actually. There's a lot of the same kind of things that happen with FME and databases, but here's some more of them. And these will be recorded and available at the URL we got there. And so, just lastly, if you want to find out more about our free training, let me just let you answer that. If anybody is interested in that, we can get back to you with that. And I think that's probably about it while the folks are wrapping up there. Other than we're going to be following up with email afterwards, pointing you at the recordings from today, so you can watch this again in slow motion if that's what you'd like to do. So anyway, I think with that, we will just go to the last slide there and bid you all adieu. Thank you so much for tuning in. Dave, I want to thank you so much for the great set of demos you put together for us today. I think it leaves folks with a good concept of the breadth of all that can be done. Really with FME and Teradata now, you're just limited by your imagination. There's no longer any technical hurdle there in terms of solving interesting spatial and non-spatial data manipulation, data import and export tasks. And I also want to especially tip my hat to the hardworking folks in the database team. Something like the Teradata reader doesn't just appear out of thin air. There's a lot of work and a lot of details to be sorted through. So thank you, Paul. Thank you, especially Raven. And of course, Alex, one of our other developers that's worked very hard on this too. So, and our friends at Teradata, thank you so much for your support to help us get to this point. I was looking back at some of the presentations. We've been working together with Teradata people since 2009, and it's very, very gratifying to see the technology evolve to the point that it is today. So thank you all. And with that, this is Dale Lutz.
And Dave Campanis.
Saying happy FMEing.
Yes, indeed.
And goodbye.